My name is Judith and this is Game On's Lesson 6 on water use. Within this lessons we will have a look at water and its related global problems, such as water scarcity, water pollution, the acidification of oceans and more. Let's start with the problem of water scarcity. From the get-go, this could sound a little bit strange, when 70% of the planet's surface is covered by water. Nevertheless, only 3% of all water is considered fresh water, and unfortunately, out of this fresh water, only 0.4% is accessible to humans. The remaining fresh water exists in the form of ice caps and glaciers, or is stored in the atmosphere or deep underground. Today, a total 1.1 billion people lack access to water. This means that, give or take, 1/7 of humankind already faces water scarcity throughout all continents. Now, how do we define how people are affected by water scarcity? We can do so by considering physical water scarcity or by taking into account economic water scarcity. Physical water scarcity is, specifically, the shortage of water. Economic water scarcity is the lack of access to water due to limited human and institutional capacities in ensuring a regular supply. All of this considered, it is expected that by 2025, 2/3 of the planet's nations will be affected by water scarcity. Yes, 2025, right around the corner. As you can observe in this map by the UN World Water Development Report, several countries in the global south currently face economic water scarcity. Now, how do we assess water scarcity? Hydrologists typically assess scarcity by looking at the so-called population-water equation. We can say that an area is experiencing water stress when annual water supplies drop below 1,700 cubic meters per person. When annual water supplies drop below 1,000 cubic meters per person, the population faces water scarcity. And when it drops below 500 cubic meters, absolute scarcity. As to the reasons behind water scarcity, there are quite a few. For instance, the different effects of climate change, which can cause shortages and droughts in some areas, while causing floods in others. We also have to take into account the pollution of water sources. Whether it is by chemicals or microorganisms, harmful substances can degrade the quality of water and render it toxic for human consumption. Moreover, there is also the salinization of groundwater, which is a consequence of the dry climate and the extensive irrigation practices in agriculture, as well as of changing the chemical composition of the natural water resources. Inefficient irrigation practices in agriculture, population growth, and poorly planned urban growth are further reasons adding to water scarcity. In the case of agriculture, it uses around 70% of the planet's available fresh water, but on the other hand, wastes 60% of it due to leaky irrigation systems. Population growth, especially in context of poorly planned urbanization, puts a greater pressure on water consumption, further draining the resources. Let's have a look at a specific case of water scarcity. Water scarcity in the Middle East and North Africa, the so-called MENA countries, involves multiple factors. Climate change leads to droughts and floods. Low water quality and poor water management are threatening, and all of this especially in the context of fragility, conflict and violence. According to experts on the MENA region during the World Economic Forum in 2015, the water crisis is even the greatest threat to the region, greater even than political instability or unemployment. And this leads to water conflict, an issue we will further discuss in a couple of minutes. But in short, water conflict in the MENA region is primarily reflected in three major river basins: the Jordan River Basin, the Tigris-Euphrates River Basin, and the Nile River Basin. So, we covered the basics of water scarcity, but we also need to have a look at water pollution. Examples are pollution through plastic, pesticides, wastewaters, industrial waste, or medical pollutants, to name just a few. Let's talk about the most famous topic first: plastics. It has an immense impact on water ecosystems. The most visible proof are the so-called garbage patches. They are large areas in the ocean where plastic and other debris floats on the surface. The patches originate from circular ocean currents, so-called gyres. Of the 5 big gyres in our oceans, 1 is in the Indian Ocean, 2 in the Atlantic Ocean, and 2 in the Pacific Ocean. Garbage patches of varying sizes are located in each gyre. Another huge problem are oil pollution and oil spills. According to the National Oceanic and Atmospheric Administration, thousands of them happen each year. Most of these spills are small, often occurring while refueling a ship, but these spills can still cause damage, especially if they happen in sensitive environments like beaches, mangroves or wetlands. On the other hand, large oil spills are major dangerous disasters. These tend to happen when pipelines break, big oil tanker ships sink, or drilling operations go wrong. Consequences to ecosystems and economies can be felt for decades following a large oil spill. Without a doubt, we also need to mention ocean acidification. This can be explained as the ongoing decrease in the pH value of the Earth's oceans and is caused by the uptake of carbon dioxide, or CO2, from the atmosphere. The main cause of the high CO2 levels, and therefore of ocean acidification, is the burning of fossil fuels. More acidic water will damage coral skeletons, and rising temperatures can lead to coral bleaching. According to the WWF, with a rising ocean temperature of as little as 1.1 degrees Celsius, coral will already drive out their algae, which gives coral its vibrant colors, and eventually cause them to die. Other reasons for coral bleaching could be low tides, pollution, or too much sunlight. Stressing reality so far, isn't it? Unfortunately, we also need to have a look at water conflicts. We mentioned the case of the MENA region as a preview, but water conflicts can arise for several other different reasons. Water resources can, for example, become a target for terrorism or for military operations to render adversaries vulnerable. Conflicts can also arise due to political decisions or capitalist-driven approaches. In this line, for example, a rather big water conflict is the case of water privatization which happened in Cochabamba, Bolivia, between 1997 and 2001. This conflict is known as the Cochabamba Water War. What happened? The Bolivian government needed to secure the provision of water in Cochabamba, Bolivia's fourth largest city, and they had to go through the privatization of the service in order to retain ongoing state loans from international funds. To ensure the legality of the privatization, they passed a law so broad and unclear that in practice it allowed the private company to not only charge for water consumption at households, but even for the use of communal water systems and, believe it or not, even for the collection of rainwater. And if that was not enough, after taking control of the water provision service, the company raised the water prices by an average of 35%. And thus, protests began, and kept on increasing, leading to the declaration of martial law to forcefully stop them. This only led, nevertheless, to more aggressive confrontations and to deaths, including that of Victor Hugo Daza, a 17-year-old student who was shot by the Bolivian army while protesting. Finally, the government had to back off, and the company had to leave. Nevertheless, universal water access is still a problem in Cochabamba today. We can also review the case of Lake Chad in the line of water conflicts. Lake Chad is an extremely shallow water body in the Sahel. According to regional researchers, it was once the world's sixth largest inland water body with an open water area of 25,000 square kilometers in the 1960s. Nevertheless, by the 1980s it had been reduced to less than 2,000 square kilometers. Remember the earlier size of 25,000 square kilometers? This was due to climate change, an increase in the population, and unplanned irrigation. Given the rate at which the lake is disappearing, it might cease to exist before 2030. The problems on site: over 30 million people live around and depend on the lake. For them it's a source of fresh water for drinking, sanitization and irrigation. It supports the livelihoods of farmers, pastoralists, hunters and fishermen. But geopolitical and terrorist conflicts around the lake have made it the most unstable region in the world. Let's talk about salt water for a change, because its importance is not to be disregarded either. Oceans are a regulator of the global weather system and carbon cycle. They transfer heat around the world and are one of the largest carbon reservoirs. They are, moreover, suppliers of living and non-living resources, such as fisheries, marine biotechnology, minerals, and renewable energy. They are also providers of goods and services, such as seafood, tourism and recreation, transport and coastal protection. And needless to say, oceans support biodiversity. Oceans are useful in countless different aspects. To name the most important ones, first of all, they are estimated to produce 50 to 80% of the total oxygen on Earth. At the same time, they absorb over 50 times more carbon dioxide than our atmosphere. For humankind in particular, they are necessary for about 50% of global primary production, including food and medicine, among others. They allow for global transport of goods, people and even carbon, thus regulating the climate. And furthermore, they also provide recreation and economic benefits, such as fishing, kayaking, surfing, and so on. Coming back to oxygen, it is produced by oceanic plankton, drifting plants, algae, and some bacteria that can photosynthesize. One particular species, Prochlorococcus, is the smallest photosynthetic organism on Earth. But this little bacterium produces up to 20% of the oxygen on the planet. That's a higher percentage than all of the tropical rainforests on land combined. As to carbon absorption, carbon dioxide moves between the atmosphere and the oceans by molecular diffusion. A difference between carbon dioxide pressure in the atmosphere and the oceans causes for CO2 to be exchanged. The CO2 moves from the air to the water when the atmospheric pressure of CO2 is higher. Then the CO2 is dissolved in the ocean because it's soluble. Another way in which the ocean absorbs CO2 is through some of its life forms. Phytoplankton and algae both photosynthesize in the ocean. They consume carbon dioxide using sunlight and release oxygen. However, as we produce more CO2 than the oceanic balance can take, the concentration in ocean water rises and the pH falls. As mentioned before, this acidification leads to coral bleaching and loss of biodiversity. We should also have a look at the importance of wetlands. What do we understand as a wetland? For conservation purposes, the definition is actually very broad. I recommend you to sit tight for a moment now, because wetlands include all lakes and rivers, underground aquifers, swamps and marshes, wet grasslands, peatlands, furthermore oases, estuaries, deltas and tidal flats, coral reefs, mangroves and other coastal areas, and I'm not done yet, they also include all human-made sites such as fish ponds, rice paddies, reservoirs and salt pans. So yes, very broad definition indeed of what wetlands are. Essentially, it's what it says on the tin. Wet lands. Nevertheless, they provide crucial services and supply a lot of our fresh water. So they are critical for human survival, but also for biological diversity, providing the water and productivity upon which countless species of plants and animals depend for survival. Wetlands are indispensable for the countless ecosystem services they provide. Flood control, groundwater recharge, climate change mitigation, and more. They are also protected by the Ramsar Convention. So, now that we know the importance of water, what can we do to protect it? So many things. For example, think of what is called black water. Sticking to the definition of the Global Water Group, black water is the wastewater from bathrooms and toilets that contains fecal matter and urine, as well as water from kitchens and dishwashers, because of its contamination by pathogens and grease. It is also referred to as sewage or brown water. An example of what we are doing wrong here: we use drinking water to flush toilets. Do we actually need to use drinking water for this? We could use instead grey water to flush them. So, what is grey water? The wastewater that comes from sinks, washing machines, bathtubs and showers. In difference to black water, it contains lower levels of contamination, making it easier to treat and process. It can and is often used in irrigation and constructed wetlands, as long as no harmful chemicals are present. Grey water can nourish plants, and as mentioned before, it can also be used for washing and flushing toilets. Where water is scarce, grey water should be very valuable. How else could we consume water responsibly? Have a look at what happened in Cape Town, South Africa. South Africa is a water-scarce and water-stressed country. Rainfall is less than the world average and is unevenly distributed. Back in mid-January 2018, after 3 years of poor rainfall, Cape Town authorities realized the city was only 90 days away from running out of water from its reservoirs. That was going to happen on the 22nd of April 2018, or Day Zero, as they came to call it. And the rainy season, if it was to happen at all after 3 years of drought, wouldn't start before May. How did they manage? Through finally addressing that there are ways to consume water in a responsible manner. With a red alert of this kind and a strong awareness-raising campaign, the inhabitants of Cape Town quickly understood the problem and started following the measures. 2-minute-long showers, flushing the toilet only when necessary and doing so with grey water, not using more than 50 liters of fresh water a day, no car washing, no filling swimming pools, and a big etc. People actually went beyond and started sharing tips through social media channels to further diminish their water consumption. As a result, Cape Town managed to reduce its water consumption by half. A city of 4.1 million inhabitants, which was using 1 billion liters of water every day, reduced its usage to 500 million liters a day, demonstrating that water had not been consumed in a responsible manner before. Thus, Day Zero kept being pushed back and back. The first strong rains came in June. By September, the water levels at the dams had risen to 70% of their capacity, after having reached only 15% at the beginning of the crisis. 1 year later, they reached 80%. By 2020, the levels were at 90%. Responsible use allowed for this to happen. So, all in all, here's what can be done to protect water. Bring about better policies and regulations regarding water use. Secure global access to water through treaties. And reuse it, both at home, but also through the implementation of treatment plants. Furthermore, desalination plants can treat ocean water to convert it to fresh water, and aquifer recharging is another option. It means that excess surface water is pumped into underground aquifers. Finally, green-blue infrastructure can secure clean water resources. Thank you very much for your attention to this crucial topic. There are even more other important aspects concerning water usage, so for an insight into the water footprint, for example, please check out the further readings.